Hello ladies and gentlemen of YouTube, this is Edgar again. Today I'm going to feature the audio generator and some test tones. A guy by the name of Kevin sent me a private message on one of the forums that I'm in, and he asked me about generating audio tones, and then it occurred to me that I've not done a YouTube video on the audio generator, and when I searched I didn't really see anything that was that much in depth or covered that much about the audio generator, so I've got this one set up on the bench, and we'll talk a little bit about it, and I'll generate some test tones with it. Now I have quite a few limitations of accuracy, so these tones won't be very accurate, and there's a lot of limitations. I mean, this is just a hobbyist type situation and by no means a laboratory, so just please endure my humble surroundings and conditions. This is a Leader LAG 26 audio generator. I purchased it back in, I think, around 1976, been quite a long time ago. Audio generators have a unique capability and a unique characteristic in that a lot of 30, 40, 50, and even 60-year-old audio generators work perfectly, and over all those years change very little from their factory calibration. One of the reasons this is true is because an audio generator is a very low power device, and none of the internal components are really very highly stressed in operation anyway. So this is a solid state unit. It uses transistor topology in the circuits, and it's totally analog in the way that it generates the tones. First thing I'll do is use my little homemade pointer, and we'll point out the front panel connections and controls and give a little bit of background on what they do. Of course, the most obvious is the power switch. This unit consumes about 3 watts. It has a switch on the back, and it can be selected to run on 120 volt American current or 240 volt European, British, Australian, and other world current. And being 3 watts and very low amperage, slide switch is adequate and trouble free. Being an old school device, uses a neon pilot light. If it ever goes out, when they go bad, they get to where they flicker and they blink, and they're pretty annoying, so if it goes bad, it'll get replaced by a small LED. Okay, we have a waveform selector. Generally in audio work, troubleshooting, design, or whatever, I use a sine wave. And this generator, and most of them characteristically, do a sine wave with less than 1% harmonic distortion. And the frequency accuracy, even though it's, well, of course it's analog and it uses a pointer and a dial, is generally 3%. And any of these old school audio generators are generally 1% harmonic distortion or less, and whatever you dial up on the dial, it's usually within 3% of the true frequency. Now this generator has a sync input, and the sync input can either be controlled by low voltage DC or low voltage low frequency signal, and it basically raises the generator's frequency with positive voltage and lowers the generator's frequency with negative voltage, so it can be used to sync the generator or to fine-tune the generator. Next we have the amplitude control. It's not calibrated, it's just a variable control. The Hewlett-Packard and other brand generators that are more sophisticated than this one may have a calibrated attenuator with step ranges. This one is just a very inexpensive. Basically it was an entry-level generator back in '76 when I bought it. I think it retailed for maybe $135 back then. So it uses a variable attenuator and then a range switch. Range switch used to be a 100 to 1 voltage, which is 40 dB, so it would lower 40 dB. I put resistors in it and wired it for 20 dB so that I could go up and down 20 dB for aligning cassette recorders, and it did indeed work great for that. Now I have a dual banana plug, and I have an unshielded cable for the output cable, alligator clips on the lower end. Here I have 680 ohm resistor that I can use. I can clip it in if I need the shunt, and I can leave it out if I don't need the shunt. So we'll pause here and reset the camera. What you're looking at now is the hookup of the generator, and excuse me. And here's basically how it works. We have the incoming signal from the generator, It's in series with this wire that goes to the push button switch. I'll key the tones on and off with the push button. You hear a little bit of 1 kilohertz bleeding through because this is a shielded cable, and the small amount of capacitance that it has is coupling a tiny amount of signal through. This is a test fixture that I use. It's got you see the dual cable, it's got RCA plugs on the other end. It can be selected for a divide by 10 or a divide by 100. So I use it for testing phono preamps a lot with this same generator. And one thing I may add about the generators is I did look around to see what was available currently, because I really hadn't. I mean, I take a generator for granted. Once you buy one, it's good for almost life. So I haven't really been looking. So I looked around and found out that you can buy a pretty respectable pocket type digital battery operated frequency generator, audio generator, for about $70. So the price has come down. That's pretty neat. And anyone who does audio work, if they can put it in their budget, ought to just go ahead and get one. They're pretty handy anyway. This one, it does real well on the bench. I'm pretty happy with it. Okay, here's a shot of the Sony MX-12 mixer. This is a vintage piece of equipment, probably around 1972. It's a little noisy, so you hear a little more hiss than you usually do behind this sound shooter mic. And I'm using it to combine the output of the generator with the output of the sound shooter microphone. And like I said before, you hear a little bit of the 1 kilohertz bleeding through. I'm going to key it a couple times. The generator's coming in on input number 1 and the mic's coming in on 2, so we'll key the 1 kilohertz a couple times. Okay, the mixer, it does have a characteristic of a drooping low frequency response, so once we get to 100 hertz, it'll already be a couple dB down. And I'll go ahead and generate all the tones down to the generator's bottom end, which is around 17 hertz. But it'll get kind of weak down there. We may droop as much as 6 dB by the time we get there. So I guess the next thing we'll do when we come out of pause, I'll show you the frequency chart of what kind of program I intend to generate. So here we go. Pause, please.